You are agree, of course, on recording. That's right.
Yes, yes.
Okay. Okay. So, okay. Good afternoon, everybody. This is Dr. Ahmed Hassan. Today we have this is one of our research seminar series in architecture and built environment. So please join me today to welcome Professor Mahjoub Elnimeiri, who will give us an important talk to our undergrad, postgrad, and also researchers as a part of the Innovative Design Lab research seminar series in architecture and the built environment, organized by Professor Patricia Tezartozopoulos and coordinated by Muhannad Abu Bakr and moderated by Dr. Ahmed Hassan. Dr. Elnimeiri is a global accomplished academic with expertise in structural engineering for high-rise buildings and long-span structures. He has made significant contributions to the building industry field through his research, publications, and professional practice, especially in the area of structure analysis, applications of computer technology, energy, and sustainability. Professor Elnimeiri holds a prominent position in the renowned Chicago-based College of Architecture at Illinois Institute of Technology, and he is the founder of the PhD program. He has received several awards and honors in recognition of his contributions to academia and the broader research community, especially in North America. Professor Elnimeiri holds a Bachelor of Science in Civil Engineering degree from University of Khartoum, Sudan, and Master of Science in Structural Engineering from Imperial College of London, and a PhD in Structural Engineering and Structural Mechanics from Northwestern University, USA. Outside of academia, Professor Elnimeiri worked as an associate partner and senior structural engineer at the renowned architectural and engineering firm of Skidmore, Owings and Merrill, Chicago, USA. And since 1991, he is the founder and president of EEC Plus Engineers International in Milwaukee, Wisconsin, USA. So thanks a lot, Professor Elnimeiri, for being with us today. I know it's very
Yes.
early in Chicago now. It's 6 o'clock in the morning, but thanks a lot for granting us some of your precious time to help our students and to help us also know more about your field, about your research, about your practice as well. Thank you. So the floor is yours. You can share your screen and we start everything now.
Okay. So I should share the screen then.
Yes, please.
Yeah. Let me. I go to share, I guess.
Yes, on the top right.
Right. And mm, so, ah, what's happening here? Hmm. Oh, maybe it's right here in the left side. Hold a second.
Okay.
Okay, share. I think now, I think I have the screen, right?
No, it's not shared
No.
yet. Yeah.
Yeah,
Next.
I go to share. Let me put this way for a second. Let me go to share screen, entire screen,
Yes.
and share.
Yes. Thank you.
Okay, so let me then minimize this.
Yes.
And now I can put it in full screen, I would assume.
Yes. Full screen mode. Thank you
Is that
so
okay now?
much. Yes. Yes. Now it's okay.
Okay, okay. Well, hello, everybody. And like Ahmed said, it is 6 o'clock in the morning in Chicago. I don't hear any car or anything. I'm the only one I think awake, but in this busy city. Uh, it's a, it gave me a great pleasure to give this lecture here when Ahmed way back and Patricia invited me. Um, Do you guys hear me all right? Hello?
Yes, yeah, we can hear you very well.
Yes.
Okay,
Yes, we can
okay,
hear you.
okay. Architecture education at crossroads, the path to a more sustainable future. I come from an engineering background, but I have been practicing and working and researching and teaching with architects. And I began, I noticed in the last 20 some years, the path of architecture is a little bit not clear, to say the least. So this presentation hopefully will give us some kind of hopefully a roadmap to a better collaborative future between architecture, engineering, and technology, and uh, which will be necessary. So this is where I will just giving you. Okay. So you probably recognize this Albert Einstein, one of the greatest scientists ever. And if you look at the diagram and learn from yesterday, live for today, and of course, hope for tomorrow. But the important thing is not to stop questioning. Questioning, we can translate it to maybe researching. You look back to go forward. Um, we look at master builder in history. It's always the connection. The master builder is encompassing. At that time, there was no definition of an engineer or an architect or a planner or anything. So there's a master builder. In this case, for example, this master builder was one of the architects and the builders for Hagia Sophia, one of the greatest accomplishment, and it was done in a very short time. Typically, way back in history, uh, such buildings will take just like the Notre Dame. It will take ages, But when you have this collaborative effort and understanding, you probably can do it in a very short time. This is where it all started, the two passes for the engineers and the architect. The Industrial Revolution, 1760 Industrial Revolution in Europe was a major event in, if you look up there, transforming social perspective, the manual labor and animal power to machine-based manufacturing. And the massive economic change and new invention of the machine, the advent of energy sources, the introduction of the factory system, and all those things created two passes. The architect stayed with the art and the ideas of aesthetics and vision, but without the tools to achieve it. The engineer, on the other hand, find himself or his hands are full to try to get involved in the physics and the development of technology. So that is the beginning of the two passes, the two direction passes that unfortunately they created this kind of problem. In America, in Chicago in particular, 1871 was an important day. There was a Great Chicago Fire, which is actually, if you look at the right side, it destroyed almost all of the city at that time. But like many events like this, disasters always lead to innovation. Unfortunately, unfortunately, people will wait for a disaster to happen, and then they start innovating. So in Chicago at that time, that was the emergence of Chicago was a major industrial city, it still is, and a major uh, place that I mean, excuse me, economically booming. And when this fire happened, so architects like Daniel Burnham, Louis Sullivan, William LeBron Jenny, these are just examples of them. And so they get together and they decided they made a master plan for the city, and they decided that the city has to go up to be built tall because uh, to be able to accommodate people and also to avoid this fire that is spread because of the woods and other things. So those household names, I hope you, especially the students, remember them and look them up because those guys started what we call the first Chicago School of Architecture, which created direction so important in how to build tall buildings. These are a couple of buildings from that era. Those buildings are still exist. Uh, the Monadnock Building, Chicago, 1891. In fact, I had a course about the first Chicago school, and the headquarters of that we used to meet. Ahmed, I think, was coordinator, and we used to meet in this Monadnock building. The importance of the building, Monadnock building in two parts, the north side and the south side. The north side is a masonry building. It was for a long time the tallest office masonry building in the world. And of course, the other building by Sullivan, Adler and Sullivan. Sullivan was a great architect, and the one in the lower side here. Yeah. And the Monadnock, the auditorium. If you ever come to Chicago, the auditorium is a place for meetings and other things. And of course, now also the University of Roosevelt is in that building. I want to make the connection with IIT, Illinois Institute of Technology. Those two slides to the left, Bohas, Miss Van der Rohe, if you, I hope that you know of Miss Van der Rohe, one of the greatest architects ever. And for us in Chicago, it's probably uh, so important because he came with the vision. He came from the Germany, of course, where he was the director of the Mahjoub, Bauhaus school. And when he came here, he decided that he wants to create a new direction because there is a new material in steel, there is a new vision, and he looked at the tall buildings around him, and then he decided that he has to take another direction, what you see it on the right. By the way, the lower right-hand corner, when I say right facing it, but it is left as far as the slide is concerned, this is Crown Hall. Crown Hall is the home of the College of Architecture in IIT, and we will see it in a minute. And Crown Hall was designed by Miss Van der Rohe. some of the faculty that came with Miss Van der Rohe, this Walter Peter Hans. And this was 1940 when Miss joined IIT. There is a course, which still is, called visual training. And those exercises are offered, they still offered. And the visual training, as you can, I'm just showing you a plate. Visual training exhibit 1944. And I'm sure you probably in your own courses at that time, of course, there were no computers, so everything was done by hand. And but it is, if you can look at it, it has beauty, it has order, it has well set proportions. Maybe I go to the next image. And order and the whole idea of this course is to enhance the visual ability of the architect, because 99% of the architect work is really visionary. You have to envision and you have to make a judgment that's consistent. Not you judge it something today, like Mies van der Rohe said, we cannot invent architecture every Monday morning. You have to be consistent in your way of thinking. And so what happened here is that there is an incredible, and by the way, there is another guy by the name is, you know, Blessing, and he was also from Germany, and he's actually he's from Switzerland, but he was one known photographer, and he photographed most of the work of the school, and he was very close to Miss Van der Rohe. I just want to make sure that everybody is hearing me all right.
Yes,
Hello?
yes, absolutely.
Okay,
Yeah.
Great. Okay, so I'm going to spend a few slides in how Miss changed things in the school and how the school looked. This slide on the right with Miss was Myron Goldsmith. Myron Goldsmith was one of the most important architects in that era. He was actually the one who started chairing this graduate master program. And Myron Goldsmith was, like I said, he was a wonderful architect. I was quoting here, reading to you. He said, I was another local boy at a third-rate Beaux Art school. This is what Myron was saying. Until Miss came out of nowhere and changes our life. And we will see in few slides to come what is that influence. Myron Goldsmith's thesis was the first thesis that dealt with the impact of scale, and in particular tall building. But the issue was in scale. Those are some of his students up there. Myron was sitting there, and you see some other. The program, that program was so important. Myron, maybe I talk about the picture to the bottom here, myself with Dr. Fazl Rahman Khan. And Dr. Khan was one of the greatest engineers I ever came across with, and he was my mentor. And the picture above it was, I was there. This is, of course, This is not very long time ago, but of course, this is the days where we were relatively very young. I think it's 19 um, to 20.
1997. 1997?
No. This is way after that. Maybe 1990, maybe 19, almost 1990, 1998, maybe, or 99. But anyway, this is a project. I want you to see here. This is a book written by one of our students, High Rise and Longest Span Research at the University of Technology, the legacy of Myron Goldsmith and David Sharp. And David Sharp is the guy um, was standing there next to me. So what is the importance of this era in the graduate program? It is we were doing research, for example, this particular, and the research was done within the studio. The studio project is usually a building, could be a tall building, could be a museum, could be whatever it is, the building. But the building, they encompass three things. One is research, significant amount of research. The other one is application. Like me said, if architecture is not realized, then it is not architecture. So, so they have to see these ideas to be realized, which I could say here, for example, this building to the right have been realized, this idea. In fact, in MIT, one of the dorms was built with this idea of the stiffening of the form. Another idea, for example, this is when I joined IIT, was my first project as an adjunct professor. I was at SOM at the time. And you can see to the left side there, this is a bridge, a longest span bridge. We try to test the idea of the bridge, how it is supported. And one of the ideas of how we use cable stays to support the bridge because we want the bridge to be very thin. So how to arrange this these stays? You have to arrange them in such a way they have to be structurally efficient, they have to be aesthetically pleasing, and they have to be part of this whole idea. And this is where this process is repeated many, many times, this connection between reality and practice and research and teaching. But also, this is one of the projects that I was involved in, which is form finding. And there is a relationship between form and structure. There is a relationship between form and architecture. There is a relationship between form and the facade. And there has to be a process that we feel that all of them, they will have to work in tandem so that we can go forward. I want to show a couple of examples that this was to the left of the project, one of student thesis. To the right is an interior center, which is a building that we did in SOM. So the research of that student, which was way, way before Interior Center was built. Interior Center was built in 1986. But this research was done way back, maybe in the 70s. So this is what I was trying to say. There has to be an impact of that research. That research has to be applied, and that research has to influence the. By the way, I forgot to mention that by this process, which started in the 40s, in the 50s. It started what is the so-called the second Chicago School of Architecture. The first Chicago school that Burnham and the others in the after the Great Fire, and this Chicago school after Mies came here and started looking into this relationship between research and construction. This is a building, was One Magnificent Mile, which is my first project in SOM. We built it in 1984, but this research was done way, way back before we looked at this. This is also an important research. There is a building in Chicago called the John Hancock Center. Anybody who visits Chicago, the John Hancock Building Center is probably one of the landmarks in the city of Chicago, one of the tallest buildings in the world, one of the most beautiful buildings in the world, and one of the building that you can call a true building that what embodied in it this idea of structural architecture. What you see is the structure, and what you see is the architecture. So you can call it like Fazra Khan called it. It is an architecture expression of the structure, or like Myron called it, it is structure expression of the architecture. So, but the idea of John Hancock Building came from also IIT. Maiko Sasaki was a Japanese student who came to IIT to study under Mies and Myron. And Fazra Khan was teaching there at Adjunct. And he came to try to figure out if we can design a tall building that can resist earthquake. Because, of course, in Japan, earthquake is an important element in the design of tall buildings. So anyway, that idea came, and then it was used for John Hancock Building. Another idea, another building in Chicago, the Willis Tower, in the tallest building, the tallest office building in the world, it still is, we think, is the Sears Tower. Again, there is a studio work that developed this idea of the so-called bundle to you. I personally had the pleasure to work with the architect, and in fact, we taught a studio at Harvard University with Bruce Graham, and I had the pleasure to work with him that semester. In fact, I spent most of my time at Harvard, and we looked at high-rise development. But the idea, again, I gave a lecture actually at Harvard at that time on this idea of the so-called structural architecture. This one is, I want to show to the left, to the left of, again, left and right, it depends on, my left was, I'm looking at it, I guess, it's Crown Hall. This is the jewel of Mies van der Rohe. He won a lot of important awards on it. And Crown Hall was built, I believe, 1958. Before I never met Mies when I came to Chicago. I came in the late 70s. But this Crown Hall, every time you look at Crown Hall, it looks crisp, like it had been built yesterday. Of course, it had been re-innovated, but it is so beautiful, so spacious. but it was designed and built by collaborative effort. A great engineer was a friend of Mies van der Rohe. His name is Frank Kornacker. He's the one who did the structure. Uh, Other of the some of the students who were working with me at his office, they also worked like Arthur Takeuchi. And and the interesting thing to know to notice about this building, if I use cost, this building when it was was built under $1 million. The whole building. On the right, this is a building by Koolhaas. This is the student center of IIT, which was built in the late to 2000, I forget exactly, but 2007 or something like this. But it costs about, I don't know how to, if you rate Sears, I mean, Miss building to this one, cost wise, this building of Schoolhouse costs about 4 times the cost of Miss. And unfortunately, is not functioning right, and it has all kind of issues and problems. So I'm bringing this. I have nothing against Koolhaas, and I think he's a great architect and a planner. But I'm talking about the idea, and I think I better talk a little bit. I would try to speed up my lecture because I think I have a lot of more slides. Here I want to digress a little bit. I keep asking myself, so what is the problem with architecture nowadays? And I said, well, let me see, look at the definitions. And I went to the Webster dictionary and I looked at structural engineering is well defined. Is well defined almost 100 years ago, and the still definition holds. Look at mechanical engineering, I looked at dentists, I looked at many professionals, and I found that they are well defined. There is only one definition and an acceptable one. But then I looked at the architecture. At that time, this was about maybe close to 15 years ago. I find there was 121 definitions of architecture. And I can show you some of them. Diana Gress was saying, architecture is really difficult. I realized that only very recently. It looks like music. You can enjoy it, but you don't know it. People like Patricia Pasco in Global Men, architecture is expected to carry too much weight in many cases. Architecture is a kind of urban ballet. And the last one, architecture is not always synonymous with building. And these are just some of the definitions. Like I said, there was 121. There are some definitions of Frank Gehry and others. So that tell you again, I'm not making judgment which definition is the right one. All I'm saying, there is no way you can handle a profession that has so many definitions and you don't know which direction you will go. So architecture education and the future. So in my own mind, I think we need a collaborative approach in architecture education. Architecture education cannot stand alone without the mechanical engineer, the civil engineer, the environmental, the manufacturer, the site requirements. There are so many things. Unfortunately for us nowadays, the advancement of technology, computer technology in particular, would make it possible to make that connection. And like I said, in my own mind, any profession will stand on three legs: research, teaching, and practice. But they have to be intertwined, and they have to have intertwined in such a way to maximize the area where they are collaborating. And maybe this is what I think: that purpose of the architecture research should be maybe qualitative research, correlative research, experimental research, simulation research, case study, mixed research, of course, and history and theory. And that leads with the architecture research in the so-called built environment. I want to show you some of the research that we were doing, and then incorporating structure in tall buildings, the left side. I will expand on those in the following slides. Ayman al-Musharraf, who is a professor now in Riyadh. He was a wonderful student, and he had both this vision as an architect, but also has a good understanding of a structure. By the way, collaboration doesn't work in a vacuum. One of the requirements of collaboration, and probably the most important one, those collaborators, they have to respect each other, and they have to be able to contribute significantly. And they cannot do that. An engineer cannot help the architect if the engineer doesn't appreciate and understand or envision the ideas of the architect. The other way around is true. The architect cannot collaborate with an engineer if he doesn't see the importance of that engineering in the process. Another research here was structure sustainability and form, and I'm going to go a little bit in detail here. Dong Hwan Ko, who is a professor now in Seoul, Korea. And by the way, I have a Professor Ray Clark and Varki Thomas and myself developed. Varki Thomas was a great mechanical engineer who was have great knowledge in the Department of Energy, and he wrote a lot of programs. And Ray Clark was a partner, a friend of mine in SOM, and he still will collaborate with me. On the right side, we have Sang-Min Park, who is also now in Seoul, Korea, and try to test the form generation. But all the testing we're doing, not in isolation. Again, it's not an exercise of geometry. It is an exercise that connected with structure, and of course with the facade, which is, and also the function. The function, of course, is architecture. Another example is space efficiency mixed-use high-rise building. Dr. Ayangal Kim, who is also a professor now in Seoul, Korea. And to the right, we looked at the barriers in the building, the barriers in the photovoltaic to be used in the exterior building. It's also the research was done by Hatice Sozer, which is now a professor in Istanbul, and she was my student. Another research at that time also by Shumnan, who is now, I think, the dean somewhere in Bangkok. And he was looking at something at that time so important. Essentially, he tried to combine the interlocking the stack effect ventilation with building thermal mass, to utilize thermal mass and to be impacted by the stack effect. The stack effect actually nowadays we call it a double skin wall. And then how that so in winter the behavior is completely different from which is the passive solar thing and night ventilation of course is different. So this is works very well in an office situation during the day. It's a very important piece of work that he did. Another important piece of work that I'm showing you some of the work. Uh, Hiroko Tamai, who is a practicing engineer and architect in Tokyo, Japan. And we were always digging into this tensile material. When you have a tensile material, how to create a form that works structurally, obviously, and then architecturally. Tensile material doesn't have form of its own. So you have to stabilize it. But how do you generate a form that works? And that was the essence of this research. Again, I don't want to go through the details, but we have done, by the way, I have to mention all these research we have published uh, together, and I myself also published. And we emphasize in our work the so-called development of form finding of tensile structure architectural approach, because we would like to see how the architect start, because the architect is a designer of the building. So we feel that the architect has to realize the importance of this material, how to develop it and make it work. Uh, this is a very recent work, and again, using modification of form based on structural design criteria. And this, of course, we're using, you probably guys know, Grasshopper and the, you know, the plugins that you can use to develop some of those ideas. This is, of course, an important thesis of Ahmed, was my student, and I think you can look at the picture at the bottom here. You see Ahmed in the middle, and his architecture advisor to his right is Peter Land, was a great, who passed away. And Peter Land was a great planner and an architect. He's just a wonderful guy. And then, of course, myself to the left, and then mechanical engineer from SOM, who was also a member of the committee. And then, of course, Professor Khan, of material engineer, in the professor at the College of Engineering. And this is a committee. We always have the PhD committees. I always try, I was of course the director of the program, and I always try to put teams for the committee that covers all the components. And this thesis of Ahmed was very important, not because he's there now, but it was very important, and I think he brought a lot of value to this, you know, bio-enclosed facade panel, and we wrote a couple of papers, important papers. One in conference in Switzerland, and another one is where did the other one, Ahmed?
It was in Germany.
In Germany. And then, of course, Ahmed won important awards, won the few important awards on this, and one of them was the gold medal of of research. And so I will continue. I just want to show you something that I think it is valuable and maybe valuable to your institution. I teach a course called, in fact, I was teaching yesterday, called Structure of Tall Buildings. This is one of my major expertise. And you can see in the top right-hand corner here, I was in class. And that is me. And Prerna Gupta was my TA. And next to me was Dr. Kim. But this class, I was teaching it also online, live, with Hanyang University. So while we are teaching here, I didn't bring the pictures of the Hanyang University, but you can see them in the screen, the students from Hanyang. And in fact, and I did this with also students in Argentina, Buenos Aires, University of Buenos Aires, College of Architecture, and also with Spain also. So this is the right-hand side. In the left-hand side, that is me with Hanyang University wind tunnel test. I asked them if we can have test one of our buildings. We were looking at wind going through the building to reduce the structural impact and to enhance the energy impact. And usually they do this for $14,000 or $20,000. So then by this collaborating with them, they said, okay, Professor Elnimeiri, we can do it for you for free. And in the top, that Dr. Muhammad Babsel, the student at that time, and that is us in the wind tunnel test in Seoul, Korea. Anyway, this is an important project that we have done, but I want just to, because I really want to make sure of the time. Yeah, I want to hurry up a little bit. So EECI Plus is my firm, consulting firm, and I can quote myself here. We capitalize on our ability to think the problem through from its inception to realization. And this is something we learned from the philosophy of Mies, that you really cannot start designing something unless you, in your mind, you think of the problem through from the beginning to the end. What is the realization is the construction. How would it be look? How would this will happen with that? I'll show you some of these projects. This one we did with Zaha Hadid in Dubai, 2013. It was a wonderful, wonderful project, and in fact, one of the last projects that Zaha was alive. Another project, Jumeirah project. Again, we did the structure for this building. This building, Kamal family, the tower. We collaborated with TVS here in Chicago, in Atlanta. And these buildings are all realized. And this one in Ethiopia. It's a bank, and we try to, the architect has some wonderful ideas, and you don't see it, but we have to wind turbines in the top to be used to provide electricity for lighting and at the building. Tower 29, in fact, we started the project, but then when the economic crash in 2008, the project did not go forward. So the last few slides, I just want to talk about the architecture, our PhD program. What is research? Um, Different people say different things. Neil Armstrong, for example, will say creating new knowledge. Thomas Kuhn, research. But if you look at all these definitions, they are connect with essentially, like Einstein said at the beginning, we're looking at something, we're trying to find something. Neil Armstrong, of course, is the first human being to go to the moon. And everything, how connect with this word research, which is to find something to go forward. What is the PhD program in our college? Research based with emphasis on application rather than theory, technology based with emphasis, of course, in collaborative work. Traditional history of the college, and this is important. The history of the college being in Chicago and the Chicago resources, like I showed you earlier, and the integration between academia and practice made this possible for us. Emphasizing a close interaction with practice and discipline. I want just to show you a couple of research projects that I brought, and of course I still bring, but it's so important. This is we architect Fars Associates. They designed this incredible building, and we were asked to monitor it, and we did live monitoring. We used our computer capabilities at that time, and these are some of the by using the highest standard, the solar power, the data control, the rainwater, the recycle. This was done about almost 20 years ago, maybe 15 years ago, which all these things that now at the time they were done for the first time. And our monitoring proved that the architect was doing the right thing. And they won the platinum elite certification, which is the highest certification. Another project, Elnimeiri University, I think I went to Dubai, and Sheikh Al he wanted to have a university which is built now and everything else, and as you can see in the bottom slide. And I think we built it again to within certain guidelines, and then we try to create a situation here because it's a university. We try to create an environment that to enhance natural ventilation, coupled with to minimize the energy use. And it was a wonderful building. These are precast, and I was there a few times. This is just to show our students where they come from, and I'm sure like your students, they come from all over the world. And we still having the same kind of, it is a wonderful experience to have a students, because this interaction between the students from different places enhance this collaborative effort. What do you look at the PhD program? To be an expert, specialized research, to be knowledgeable and cutting edge, to be a teacher, to be vision, teaching, research, like applying discipline skills. What is your value in practice? Expertise, insight, new vision. And this could happen not just a PhD, it could happen for a master's degree. I think I don't want to talk about this. This is a couple of projects just to mention. This one at the time also it was way. We look at the urban heat island effect, which comes from the building next to the other building, the impact, the street and heating. This one, it's a dear project to myself because my student, Tila, who is now professor at University of Khartoum, did an incredible work on this so-called courtyard and looked at it. He did a lot of simulation and testing. This is the slide before last. A friend of ours, Ken Yang, and I hope you guys know about him. He's an architect who has a PhD also from the University of Cambridge. And he wrote all these books at the bottom. He's the father of this idea of the eco-design. And he believed that, and he wrote a book about the skyscraper. I was privileged to know him. He came and worked with us helped us for about 3 weeks. And Ken Yang, originally from Malaysia, but he's just an incredible source of knowledge. And so if you guys look at this name up, and maybe you can invite him one day to say something. And this is my last slide. I always think about it, why we're doing all this. At the end, to make this world better and to benefit the unprivileged. And I'm looking here at those kids from Africa. To the right, you see how the world is and how the global warming is to do it. And for that, in that, I stop here and I will stop sharing. Is that true, Ahmed?
Yes, yes, please.
Okay. Well, thank you very much, guys.
Thank you so much, Professor Elnimeiri. Thank you so much for this interesting talk. You took us for a very long tour, actually, in the history of tall buildings and structures and the interrelationship between structures and architecture and how it's important throughout history and why we are having this dilemma today, that we are having two paths for architecture and structures. So you are now looking for more collaboration between them, because actually this is what life is and what we are learning actually from the new project that has been done now all over the world, that it's icons now, that this is a golden opportunity for architecture and structures and other consultants to be collaborated into an interdisciplinary approach, not like before, separated path. So thank you so much. I will try to open now the questions to our students and our researchers and our colleagues as well. So please, if you have a question, open the camera, raise your hand, and speak up. Don't be shy, guys. So Tariq, do you have any question for Professor Elnimeiri?
I will go with
Suhaila.
that one.
Okay, Mohanna, go ahead.
So first of all, thank you very much for Professor Mahjoub for this inspiring and informative informations. And I'm always when it coming to my mind when you are to see like a complicated projects and skyscraper, especially in the era between 1970, 1980, and 1990, where it wasn't in that time that's, let's say, advanced digital tools. So it's always like for us to, when we are looking for this project and the structure and the challenges, how they made this calculation without having this advanced digital tools. So that's from our perspectives, from architects, architectural perspectives, it's a big challenge. So I would like you to highlight some key points about these challenges without having this advanced digital tools.
Right. So, can you hear me?
Yes.
Okay. So, this is important because when I joined SOM, Skidmore in Chicago in 1979, 1980. I did my PhD in actually, I developed computer programs and I developed finite element programs. In fact, uh, they were wonderful. So when I came, Fazl Khan was asking me, you know, when we did John Hancock Building, it took us because there is also one machine called the IBM 560, and 560, I think it is only, they are not even megabytes; those are kilobytes. 560,
Oh,
which is, and so they used to have. He was telling me we used to have cards, and we put them in the machine, and the machine will run overnight, maybe 12 hours, to try to solve just one part of our problem. They have to develop methodologies. They cut the building into pieces, and they did all kind of things. He said it took us 6 months to analyze John Hancock building. 6 months. At that time, that was 1980. He said, "Can you do it in whatever?" I said, "Well, let me." So I did it actually in 2 weeks. That was
no.
1980. So now, right now, we are working on a couple of projects at this. While we are speaking, me and the guy who was doing with me the analysis using uh,
ETABS?
within the BIM environment, we
Mhm.
get the architecture and we use it and we'll put it in and then we write our own sometimes plugins. While we are discussing the architecture, in less than 2 hours, we are finishing the design of a tall building, the analysis. So answering what Mohammed was saying, the technology now is so advanced. And one of the worries that I have, all this, even when you look at like 3D printing and many other technologies, they are so advanced. The worry about it, or even in the BIM itself, even for the students in the class, they get trapped in keeping pace with the computer. So in the evening, probably the student will finish the design of the whole facade and everything else. But how does it work? Will it work? It cannot work unless the student and the professor, they know, like I said earlier, they know what it is they're looking for. How this connection between this facade and the structure. What about the glass? The glass supposed to is it a double skin glass, one single skin, double pane, single pane? What type of glass? What happens if somebody throw a stone in that glass? So answering your question, this is my simplest definition. We have to keep pace with the technology, but we have to control it. We have to be the designers. We have to be we have to use the computer as a tool, not as something else. So this is what my answer is.
Thank you very much. Thank you.
Thank you. This is great. So, how about other students and other researcher, Josine, Claire? Do you have any question to Professor Mahjoub, Tariq, Suhaila? So please also speak up if you have a question so far.
Hi, thank you for presentation. It was very useful, and actually, at the moment, I don't have any question to see
Okay, okay. Suhaila actually is doing her dissertation now. It's undergrad, but her project it's about vertical gardening, okay, and about vertical farming, and we were talking about something about the form development, okay,
Yes.
and the effect of the wind load actually on the form and geometry, because usually now the students started to quote me all the time, respect the geometry. Okay, so we are doing this some exercises, and I know that you have published a paper about that, about the
Yes.
effect of the wind load on the shape and the form of the building.
Yes. Yes. And I think just comment on this. We wrote few papers. One of my students who is now professor in Iran and some other students. So it is important that what kind of shape that you need to handle the wind. You wanted to make a natural shape that diffuse or confuse the wind to avoid
The wind load.
vortex shedding, to avoid any instabilities that could happen to the wind. You know, if you look at the plants, the way some of the plants, you know, sometimes wind storms comes in, and tomorrow you look at the tree, everything is fine. They bend in certain way, they have a certain direction. So that form, what we call it form modification.
For modification.
You have to modify the form, and you have to do it. You cannot modify it just once. While you are modifying it, of course, it's subjected to that wind. Sometimes you use an incremental approach. Sometimes you use approaches. But yes, you can handle it.
Okay.
Okay,
Okay.
Thank you very much.
Okay.
thank you, Suhaila. Thank you so much. Okay, Mohammed, the mic is yours now to close
Yes.
the
So if
session
there's
today.
no any further questions or comment from student or the colleagues, I would like again to thank you, Professor Mahjoub, to contribute today. And there is a question
Tariq,
from
okay.
Tariq. Okay. Go for it, Tariq.
Assalamu alaikum. It's not a question. I just wanted to say thank you, Doctor, for a really interesting, fascinating talk. And it's always a privilege. It is a privilege to meet my teacher's teacher.
Yes.
So that's, it's just a shame it's so short, because I think I would have loved to have this been a much longer seminar to hear you talk about the philosophy of architecture. I think there's a lot more we could have gone into, but thank you. It was beautiful. It was really nice. Thank you very much.
Thank you.
I'm shy now, Tariq. This is something because Professor Mahjoub is not just my mentor and my advisor and my teacher. He's also my elder brother. I'm relying a lot on his wisdom actually in my life. I've learned a lot from him, and my time actually in IIT when I was a student there, it was one of the most valuable time for me to learn from him and also from other professors, and that's why I'm keen to convey this kind of value to all of you, because your relationship to your mentor, your advisor, your teacher is something that you need to value for life. Okay, and that's why this is very important in architecture to have this feeling. We are just one family, and we are learning from each other, and we are building actually on the experience, on different experience. And I quote one time Professor Mahjoub, actually he told me about this quote before about Isaac Newton. Do you remember?
Yes.
If I'm going to see farther, because I am standing on the shoulders of giants.
Yes.
So, and I'm glad that we have one of the giants here with us today. So this is I'm honored actually to be one of his students. So thank you so much, Tariq, actually for this soft comment. I love it. And Claire, do you have any kind of comments you want to add?
No, I just wanted to say thank you, and I've not really got any questions or anything, but thank you for the presentation, and some of the buildings that were on there were inspirational, really. So thank you for that.
Thank you so much.
All right.
Great. So I will again thank you, Professor Mahjoub. Thank you, Dr. Ahmed, for being here. Thank you for our researcher student and who's attend this today's seminars. And we're looking forward to see you next week. And thank you very much.
All right.
Thank you. Thank you.
Thank
Thank
you.
you very much.
Bye-bye.
Thank you. Thank you. Have a good day. Thank you.